Hello all, and thank you for listening to Mr. Laxton's video on these Algebra 2 Section 3.1 notes. And again, to start this Chapter 3, make sure you hit the subscribe button down low, and you can see all my videos and get all of the videos when I post them. Alright, awesome. So, Section 3.1 is solving linear systems by graphing. So, really the whole Chapter 3 is solving these linear systems. And to just jump in here, a system of linear equations is two or more equations in the same variables. So as I look here, I have two equations. We're always going to have these two equations. They might be in y equals mx plus b, they might be in standard form, who knows. But these systems of equations, we're going to look to solve them. And a solution to the system of equations is an ordered pair xy that satisfies each equation in the system. So we're going to look at today is specifically graphing. If I just talk about this real quick, we have two lines. So let's just say our first line looks like this. We have two equations. Let's say that's our first line. And then our second line, let's say our second line might go like, I have no idea, let's say it goes like this. Alright, so that's our second line. So the solution to this system is going to be this point right here. That's the point in which they intersect, and that's a point that's going to work. It's going to be true in both of these equations. So it's going to be a solution to the system. Okay, so that's what we're going to look at today is first of all by graphing. So we're going to graph some lines, and really just as simple as that, we're going to see where they intersect. And then in the next couple sections, we're going to solve them by using algebra skills, and then that's going to give us an xy point in which they intersect. Alright, so sometimes the graphing is going to be easier, sometimes the solving is going to be easier by elimination, substitution. We're going to talk about those in the next couple sections. But here we go. It says determine here if the following are coordinates, if the following coordinates are solutions to the systems. Excuse me. So the first one, it gives us an x and a y. 3 and -3, and really all we're going to see is we're going to plug these guys in, and does it make it true? Does it work? In order for this to be a solution to the whole system, it has to work in both equations. Has to work in both equations. Alright? So here, let's plug these guys in. So the first one, I have 4 times 3 plus -3 is equal to 9. Is that actually equal to 9? So 4 times 3 is 12. Plus a -3, is that 9? Is 4 minus 3 9? Sure it is. 9 does equal 9, so yeah, that checks off. That works in that equation. But now, in order for it to work in the whole system, it's also got to work in this guy over here. So now I have -2 times 3 minus 5 times -3. Is that also equal to 9? So if I plug this guy in, I get what? I have -2 times 3 is going to be -6. I like to make this plus a negative, so this is going to be -5 times -3, which is 15. -6 plus 15, is that 9? And you say, hey, sure, that does. 9 equals 9. So yes, 3 -3 is a solution to this system. So this is where 3 -3 is where these two lines would intersect. Okay, but now let's check another point. Maybe these lines are right on top of each other. Maybe they're exactly the same line. So this point over here, 2, 1, could work. We have to try it to see if it does. So let's plug in 2, 1. See if it works. So let's plug this guy in. I get 4 times 2 plus 1. Does that equal 9? 4 times 2 is 8. Plus 1 equals 9. Does 9 equal 9? Sure it does. Check that guy off. It works. Now, as I go on through here, we got to look through in the second equation. I have -2 times 2 minus 5 times 1. Does that equal 9? All right, -2 times 2 is -4. This is going to be plus and negative, so this is going to be plus and -5 is equal to 9. -4 plus -5 is -9. Does that equal 9? No, it does not. So this guy is no. It works in one of the equations, but it does not work in the other, so it is not the solution. All right, awesome. So here we go. Steps of solving systems of equations by graphing. I'm not going to spend a whole lot of time on this because this isn't really that bad, but really it's got step-by-step out for you here. We're going to graph both these lines, so we're going to change them both into slope-intercept form. We're going to graph them, and then we're going to determine which point these two guys intersect. All right, and that's going to be our answer. And we could check it algebraically in both equations to make sure it does work, kind of like we did up here for you guys. All right, awesome. So here we go. We got to get these guys into y equals mx plus b. So I have to get y all by itself here. I got to subtract the x. I got to subtract the x. So now I get y equals negative x minus 2. All right, that's in y equals mx plus b. The second one's a little tougher. You got to subtract the 2x. You got to subtract the 2x. So I have negative 3y is equal to negative 2x minus 9. And then I get to divide by that negative 3, so that's why this one's a little bit more difficult. So now I get y equals 2/3 x plus 3, because negative 9 divided by negative 3 is a positive. All right, so here we go. Let's just go through and graph these. I'm going to graph this blue one first. Y equals negative x minus 2, so that's got a y-intercept at negative 2. I go down 1 over 1, down 1 over 1, down 1 over 1. So for these, we're trying to find this point of intersection. So sometimes I like to kind of take up some of the whole graph here just to kind of know that those are my points. So now I'm going to connect these guys with that line. Bang, bang. Awesome. Now I got to go graph the green one. So my green one has a y-intercept of 3. And then I go a positive slope of 2 over 3. So I go rise 2, run 3. I can go down to left 3, so you kind of notice here my point was a little off there, but notice that, hey, those points are on top of each other. That's what we like to see. So this point right here is on top of each other on both lines. So that is going to be the solution to my system. So as I look here, that point right there is negative 3. Ooh, I meant to write negative 3, not negative 1. And go away. Wow, struggling here with my eraser. There we go. All right, so my point is negative 3, 1 is my solution. Now it says, hey, you can check these guys algebraically, so I just plug these guys in. So I plug negative 3 in for my x. So in this equation, I have x plus y equals negative 2, so negative 3 plus 1, does that equal negative 2? Obviously, negative 2 plus 1, or negative 3 plus 1 is negative 2, so negative 2 equals negative 2. Yes, that works. Now I go through and plug in the second one. I have 2 times negative 3 minus 3 times 1 is equal to negative 9. So this is going to be negative 6 minus 3 is equal to negative 9, and negative 6 minus 3 is equal to negative 9, so these guys, hey, that checks out too. You can always check yourself algebraically. So the answer we're looking here is that negative 3, 1 is the solution to this system. So pretty straightforward there. Just go through and graph those guys and then find out that point of intersection. All right, so there's kind of 3 different types of solutions to linear systems. And these ones are just kind of 3 different types of lines. And we're going to look at how this works algebraically too. But if the lines intersect at a single point, just like we just had up here, we had a blue line that goes down like this, and we had a green line that came kind of up like this. This point right here was my one solution, okay? That's kind of the most normal thing that you'll see. And these two, number 2 and number 3 here, are kind of the special solutions, I would say, the special ways. All right, so if the lines are parallel, so let's say that we graph 2 lines and that they're exactly parallel. We talked about that. Parallel lines have the same slope. So if these guys have the same exact slope but different y-intercepts, there is no solution. There is no point that makes these 2 equations true. All right, so there's no one point. These guys has its own separate points over here. This guy has his own separate points over here. There's not one point that they both share in common. They're never going to intersect. All right, and the last one here, if you have the same line. So let's say that we have some different equations, and then we get some line, or let's say we get them into y equals mx plus b, and those lines, like there's a green line, let's say the blue line's directly on top of it. All right, so they're the exact same line. If they're the exact same line, there's infinite number of solutions. They have the same slope and the same y-intercept. All right, they're graphed right on top of each other. Every single solution on the blue line is on the green line. All right, so those are kind of the 2 separate, kind of the special cases, I guess you could say. All right, so there we go. That is how we solve systems of equations by graphing. Get those lines into y equals mx plus b. Graph them and find that point of intersection. Thank you for listening again, and have a good rest of your day.